So before we get into graphing some transformations, let's look at some definitions that I think you're probably familiar with. First of all, a function that repeats its values in regular intervals is a periodic function. Periodic just means something's repeating itself over and over again. The trig functions are periodic. Okay? The length of each interval or cycle is called the period. So that part that is repeating is called the period. If you remember the period for sine and cos, the period was 2 pi. The period for tan is just pi. All right, the sine and cos graphs are what we call sinusoidal function. I know that seems weird that we call the cos graph sinusoidal, but they're both sinusoidal. They just mean that they have this wave. Okay, the amplitude, we've already talked about what the amplitude is. That's the distance above or below the midline. And then recall this. So this is the transformations of a graph. And what we're going to do for the function, we're either going to put sine or cos in there. Usually, we are not going to do the tan graph. Okay, so you probably don't need to worry about that one. So let's take a look at what each of the parameters does to the graph. If we change the value of a, well, the value of a is the amplitude. It's going to tell you how much it's going to go up and down. So in this case, what is the amplitude? It's 2/3. What is the amplitude here? It's 4. The negative is just going to be a vertical flip. Okay? So let's sketch a graph that has a different amplitude. Okay, instead of just y equals sine x and y equals cos x, we'll take a look at the different amplitude. Now this is pretty simple. What you're going to do is draw the original graph. So if we're going to draw the sine graph, let's quickly put that down on this axis. Okay, and you know the sine graph looks like this. Okay. There's the sine graph. Now the only difference is this 2 changes the amplitude. So it's going to be from 2 to -2 instead of from 1 to -1. Okay? Let's try the same thing with the cos graph. Again, we need to be pretty good at this already. Let's graph cosine. Okay, and now normally it would be 1 and -1, but I'm not going to put that in yet. I'm just going to graph the cosine. Okay, and instead of 1, I'm going to put 1/2 and -1/2. All right. This is x. That's y. All right, so that's the first thing. Amplitude is a pretty easy transformation. Let's now look at the period. This is probably the trickiest one. Okay, the period, remember to do the period, you're going to take the normal period and divide by the value of b. Instead of multiply by b, you're going to divide by b. Okay, for tan, you're going to take the period of pi and divide by b. So let's take a look at this. Determine the period of each function. So the b value is 6. So the period for this one is going to be 2 pi divided by 6. Okay, here b is 2/3. So the period would be, now period of tan is pi divided by 2/3. Okay, and what is pi divided by 2/3? That's pi times 3/2. So you're going to get 3 pi over 2. All right, b here is 1/7. So the new period would be 2 pi divided by 1/7, which is the same as 14 pi. Okay, so how do you graph these? Well, let's take a look at the first one. Here, my b value is 2. So I'm going to start by drawing the sine graph, and I'm not going to put any markings in. I just know that the sine graph looks like this. Okay. Now normally this would be 2 pi here, but you can see that there's a b value of 2, so I'm going to write something called the new period. The new period is 2 pi divided by the value of b. So the new period is pi. And then the new intervals, okay, remember there are always 4 intervals. So I'm going to take the new period, which is pi. All right, I'm taking pi and I'm dividing it by 4. So this is going to be pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, and 4 pi over 4, which is pi. My amplitude is 1 and -1. Okay? Let's try this graph. So start by drawing the cosine graph. Okay, and then let's look at the new period. Remember, the old period is 2 pi. The b value in this case is a half. What's 2 pi divided by a half? That's 4 pi. So that's the new period. Now what are my new intervals? So what I'm going to do is take the new period, which is 4 pi, and divide by 4. This gives me pi. So that tells me I'm going from pi, 2 pi, 3 pi, 4 pi. And the amplitude is 1 and -1. Okay, so that's how you do those graphs. Typically, that's the easiest way. Sometimes you have to draw the original graph first. We'll do some of those coming up. But this is the way I would draw these graphs whenever I have an option. Okay, let's talk about the phase shift. The phase shift refers to horizontal distance. So that's a little bit, we've never talked about phase shift before. We've always just talked about moving left and right. With the trig graphs, phase shift is horizontal shifting. Okay? So what is the phase shift? Well, if we see this, we would say that's left pi over 4. So the phase shift is left pi over 4. You might also just see this as the phase shift is negative pi over 4. Okay? Here the phase shift is right pi by 6, or maybe you'll just see it's the phase shift is positive pi by 6. Sometimes they don't give you the direction, they just make it as a positive or negative. Negative is left, positive is right. Okay? Now this, when you do a phase shift, I'm going to suggest that you draw the original graph first. Okay? So let's do that. Okay, there is no amplitude change, so I can just draw this graph with the same period and the same amplitude. But what I'm going to do is I'm going to shift it now. What is pi by 2 here? This is a phase shift of pi by 2, in other words, to the right. Okay, so I'm going to move it pi by 2 to the right. So this point will move to the right here. This point will move pi by 2 there. This point will move pi by 2 to the right. It will go here. This one would go here. And this one would go to 5 pi by 2. And so my transformed graph looks like that. Okay? Now, it's nice if you label some of these points. So this is 2 pi, -1. What's this point up here? This is pi, +1. Okay, that's your new graph. Let's try this one. So this is a phase shift left pi. So we'll put the original coast graph. And since I see that I'm going to move it left pi, I'm going to go backwards a little bit already. Okay, so here is the original coast graph. And if I want to move left pi, this point would go there. This one would go here. This one would go here, to there, and to there. Okay, and we should label that somehow. This is cos theta plus pi. Oh, sorry, it's not theta, it's x. Okay, now the only thing that sometimes, like what we did there is we graphed one period. Sometimes it gives you a specific domain to graph it over. So this is just one period. What if it said we were supposed to graph it from 0 to 2 pi? Okay, right now we're ending at pi. So we would have to continue that graph. You know, we would have to put a few more dots here and we would have to keep going like that. Okay, just make sure you read the question and that you do it over the domain that it is given to you. All right, the last transformation is what to do with the middle. So this is moving it up and down. This is a vertical translation. Okay, what is the middle going to be here? -1. What would the middle be here? So this would mean it was going to go down 1 unit. Okay, and this one will say it's going to go up 3 unit. So that's all it means when we say the middle is 3 or the middle is -1. Okay, so how am I going to graph this? Well, again, like every trig graph, I would start with the basic graph. Okay, and then look something like that. Now, what we want to do is we want to move it down 2. Okay, now you can't move this line. We can't just say, oh, if we want to move this down 2, why don't we just say this becomes -1 and this becomes -3? You can't do that, okay, because this is the line y equals 0. That can't change. Okay, so we actually have to move all of the points down 2. So here's -2. This one will go down 2 units there. This one will go down 2 units here, down 2 units here, down 2 units there. I'm going to label this one. So this is 3 pi by 2, -3. And then there. So you have this graph. Okay, and you'll see the midline now is at -2. All right, I'm going to leave the last one because that's pretty straightforward, just to move it up 1. What we want to do is we want to get into graphing more than one transformation. So these are all of the transformations we've talked about in other graphs. We're now going to apply them all to the sine and cos graphs. Okay, so very quickly, A affects the amplitude, B affects the horizontal stretch or compression, C left or right, D up or down. Okay, so we'll stop there.